Ever wondered how robots can predict and avoid collisions, just like a self-driving car or a warehouse robot? What if I told you that you can build a neural network to do exactly that, completely from scratch using only C++? Welcome to this brand new series, where we create a real-world AI application step by step. But what the project is about? In this series, we're not just learning theory, we're building something practical. A neural network that takes real sensor data and predicts whether a robot is about to crash. This is a full-stack AI project in C++. No libraries, just you and the code. Here's a quick look at what we'll build together. A neural network class, activation functions, and layers trusted to build custom architectures. Training the model using stochastic gradient descent, binary cross entropy, and backpropagation. Evaluating performance using real metrics like accuracy and F1 score. And yes, saving and loading your trained model just like the pros do. Let me walk you through what we'll cover in each part of the series. We'll design a flexible system so you can define your layers like this. Whether it's 3 layers or 30, and how many neurons you want in each, a layer.hpp, matrix.hpp, and neural network.hpp files will handle it smoothly. We'll build our own matrix class from scratch to handle all the core operations our neural network needs. Creating matrices, indexing, random initialization, scalar multiplication, all from scratch. Forward pass and backpropagation. We'll go deep into how your model learns by calculating gradients and updating weights manually. Loss and optimization. We'll use binary cross entropy as our loss function and stochastic gradient descent to optimize our model. And yes, we'll train using best of data instead of one example at a time. That means faster and more stable training. We'll also include a dynamic learning rate that adjusts over time to improve performance. Model saving loading. Train once, use forever. We'll save our model to a file and load it later for predictions. Working with real data. We'll use a real data set, which contains robot sensor inputs. Our CSV loader.hpp will handle all the parsing and pre-processing. Data splitting. You'll learn how to split data into training and test set to evaluate generalization. Model evaluation. After training, we'll test the model and evaluate how well it predicts collisions. Confusion matrix and metrics. Finally, we'll implement and explain metrics like accuracy, precision, recall, and F1 score to measure performance like a data scientist. Why you should follow along? If you are a C++ developer, a robotics enthusiast, or just someone who wants to understand AI from the ground up, this series is for you. You'll get a deep understanding of how neural networks really work, and you'll see every single line of code that makes it happen. What you need to get started? All you need is a C++ compiler and a text editor. No third-party libraries, no black box magic, just code that you understand and control. Ready to build a real-world neural network with your own hands? Hit that subscribe button so you don't miss the next episode. Drop a comment if you're excited, and let's bring this neural network to life. See you in the next video.